Hello, this is a review question for CEE 353, Civil Engineering Materials at Arizona State University. The problem that we're going to be going over today is out of the textbook, and it's problem 5.26. If you have your textbook, if you want to open it up, I'll read the problem statement out and then write the givens. Uh, but the problem statement says, laboratory specific gravity and absorption rates are run on two coarse aggregate sizes, which have to be blended. The results are as followed. So aggregate A has a specific gravity equal to 2.814 and an absorption equal to 0.4%. And then aggregate B has a specific gravity equal to 2.441 and absorption equal to 5.2%. Now these are all our givens. And from there, the first part of the question asks, what is the specific gravity of a mixture of 50% aggregate A and 50% aggregate B by weight? So part A, we want 50% aggregate A and 50% aggregate B by weight. With that, what we're going to do is we're going to use the composite specific gravity equation, which is G equals 1 over the decimal fraction by weight of the aggregate. So we're going to label that as P over the specific gravity. So this is PA and GA plus PB. So that's the decimal fraction of the weight of the aggregate of B over the specific gravity of B. From here, we're just going to plug in the knowns that we have. So it's 1 over, the fraction is going to be the 50%, so 0.5 over your specific gravity of A, which is 2.814. And that is added to the fraction of aggregate B over the specific gravity of B, 2.441. Now the reason this could change, the percentage can change in any problem. So if you had a 60-40 or 70-30 mixture, the only thing that would change is the PA and PB. But for this problem, it's 50%, so it's actually pretty easy. And then just using your calculator to solve, you get the specific gravity of the mixture. It equals to 2.614. So that's part A, so solving for the specific gravity of the mixture by weight. And then the second part is to solve for the absorption. And so what we're going to do, so part B, the absorption is pretty straightforward. So absorption in the equations is a capital X. And all we're going to do is multiply the same decimal fraction by weight of the aggregate, so PA, times the absorption of A, plus the decimal fraction of the aggregate by weight of B times the absorption of B. And the absorption is given in the equation, the percentage. You can convert it over into a decimal form, but since both of them are in percentages, and we want the total absorption in percentage, we can just leave it in percentage form. And what we'll do is, this one is 0.5 because of the 50% mixture, times 0.4% plus 0.5 times 5.2%. And then it's just plug and go from there. 2.8% is going to be your total absorption of the mixture. This problem is pretty straightforward. The main thing that I can tell you guys is that when you're given a problem, go through and write down all the givens. Make sure you understand what it's asking for and specifically what equations you can use. But hopefully this helps a little bit, and I hope that you have good luck on your test coming up.